Hey students, this is a video on section 4.4, adding and subtracting like fractions. So what are like fractions? Like fractions mean they have exactly the same denominator. Okay? Like fractions have exactly the same denominator. Exactly the same denominator. Okay, so the numerators will be different, but in order to be like fractions, they have to have exactly the same denominator. So the bottom has to be the same. All right, and it's actually a lot easier to add or subtract like fractions, so that's why we're learning about like fractions first. And then in the next video, we'll be learning about unlike fractions, which are more difficult. Okay, so we're going to do this by example. Example. The instructions here are add or subtract. Add or subtract. All right, and for problem number 1, we're going to do 1 over 5 plus 2 over 5. 1 over 5 plus 2 over 5. Now, as you can see here, we have exactly the same denominator, so these are like fractions. So how do you add or subtract like fractions? Well, it's actually pretty straightforward. To add or subtract like fractions, in other words, fractions that have exactly the same denominator, sorry, I'm having trouble with this pen again. To add or subtract like fractions, what you do is you keep the denominator and you add or subtract the numerators. Okay, so keep the denominator and add or subtract the numerators. Okay, so it works different than multiplying or dividing because you're just going to be keeping the denominator and you're only going to be adding on the top. Okay, so like here, we keep the denominator, which is 5, and then we add on the top. So we have 1 plus 2 is 3 over 5. Okay, so our answer is going to be 3 over 5. So all we did there was, because they're like fractions, they have the same denominator, we kept the denominator and we added the numerators. And that's actually the whole problem. Of course, you want to simplify this fraction that you get, if possible, but 3/5 is already in lowest terms. So that's going to be our answer. Okay? So that's really not too bad, hopefully. It makes a lot of sense. Okay, example number 2. Example number 2. For this one, we have negative 7 over 20 plus parentheses negative 11 over 20. Okay, so negative 7 over 20 plus parentheses negative 11 over 20. So what's new about this one is we have minuses. And remember, when you're adding, if they both have the same sign, you keep the sign and add. Okay? So because these are both negative, we're going to keep the negative, and then we're going to add the numbers. But because these are like fractions, we also keep the denominators. Okay, so really what we're doing here is we're doing -7 plus -11, and that's going to be all over 20. Now, why is it -7 plus -11? Well, there's a minus here, so that refers to this 7 on the top. And then there's a minus there, that refers to that 11. So that's how we get -7 plus -11. And then because these are like fractions, they have exactly the same denominator, so we kept the denominator, which is 20. Okay? And then -7 plus -11 should give you, because they're the same sign, you keep the sign and add. Okay, so 7 plus 11 is 18. So we actually get -18 on the top. Okay, so we should have -18 over 20. And then we're not done. So for this problem, this fraction is not in lowest terms, which means we need to divide the top and the bottom by any common factors. So if you think about 18 is 9 times 2, and 20 is 10 times 2. Okay? So we can divide the top and the bottom by 2. So that's a common factor there. So we'll go ahead and divide the top and the bottom by 2 to simplify the fraction. Okay, so after we do that, I can bring this minus out front. So we're going to have minus, 18 divided by 2 is 9. And then 20 divided by 2 is 10. So we get -9 over 10, or -9/10. And remember, if you have a minus like this, you're allowed to bring it out front. You're also allowed to move it to the denominator. Okay, so a minus in the numerator is the same as a minus out front, which is the same as a minus in the denominator. So that's why I was allowed to take that negative there and bring it out front. Okay, but there's no common factors for 9 and 10, so that means we're done. Okay, so our answer is -9 over 10. Okay, cool. So that was problem number 2. Example number 2. Okay, and example number 3 is going to have a little bit of variables. So I wanted to do a problem with variables. So for this one, we have -7x over 15 plus 2x over 15 plus 2x over 15. Okay, so -7x over 15 plus 2x over 15 plus 2x over 15. So believe it or not, because these all have the same x, these are actually all like terms. And they actually have the same denominator, so they're also like fractions. So here, we're basically just going to keep the x and also the 15 as the denominator. And we're going to combine each of these. These are both like terms and like fractions. They're like terms because they have the same variable raised to exactly the same power. And then they're also like fractions because they have the same denominator. So all we really have to do here is add or subtract these numbers in the front. Okay, so we're going to be doing -7 plus 2 plus 2. Right, so we're really just doing -7 plus 2 plus 2 because we keep the variable the way it is and we keep the denominator. So -7 plus 2 is going to give us -5, and -5 plus 2 gives us -3. Okay? -3. Okay, but then we still have everything else. So we actually have -3x over 15. Okay, so we're going to actually have -3x over 15. So all I did there was I noticed that we have exactly the same variable and exactly the same denominator. So then I went ahead and did the numbers in the front. So I did -7 plus 2 plus 2, because you just keep the variable and you keep the denominator for like terms and like fractions. Okay, and then -7 plus 2 is -5, plus 2 is -3. So that gave us our answer, which is -3x over 15. Okay, so remember, like terms and like fractions work the same way in that you keep the variable and you keep the denominator, and then you add or subtract the coefficients, so these numbers out front, up in the numerator. Okay, so that was example number 3. We're moving right along here. All right. And most of your homework is not too bad because it's like fractions. So like fractions aren't usually that hard. But there are a couple of things you might not be sure about. So I wanted to talk about that. So let's do example number 4. We're going to do 4x over 3 minus 1/3. Okay, so 4x over 3 minus 1/3. Now with this one, these are like fractions, so they do have exactly the same denominator, but they're not like terms. Okay, so this term has an x, and this term doesn't have an x. So those aren't like terms. But what we can do is we can still subtract. It's just we can't combine like terms. So here on the top, we keep the denominator and we add or subtract the numerators. So we're doing 4x minus 1 on the top. And then on the bottom, we have 3. Okay? So our answer is 4x minus 1 all over 3. Now the reason I couldn't combine the 4x and the -1 is they aren't like terms. This term has an x, and that term doesn't have an x. So we can't combine them. However, they were like fractions, so we were able to keep the denominator and then subtract on the top. Okay, so this is actually as simplified as it gets. So our answer is going to be 4x minus 1 all over 3. So that one's a little bit strange looking, but it's actually pretty easy once you realize it. Okay. Okay, example number 5. Example number 5. For this one, we have -9 over 100 plus 99 over 100. -9 over 100 plus 99 over 100. All right. So once again, these are like fractions. So we keep the denominator, which is 100, and then we add or subtract the numerators. Well, the numerators here are -9 and 99. So what's negative 9 plus 99? Well, remember, if they're opposite signs, you keep the sign of the larger number, and then you subtract. So here the larger number is positive, so our answer is going to be positive. So we're going to do 99 minus 9 is 90. But it's going to be positive 90 because we kept the sign of the larger number, which is 99. Okay, so that's going to be positive 90 over, well, we go ahead and keep these denominators. So we're going to have positive 90 over 100. However, we're not done, right? Because we can still simplify this. So what's a number that goes into both 90 and 100? Well, if you have a 0 at the end for both your numerator and your denominator, that means you can divide the top and the bottom by 10. So that's what we're going to do here. We're going to divide the top and the bottom by 10. Okay? So on the top and the bottom, those zeros just cancel out. One of the zeros cancels out whenever you divide by 10. Okay, so on the top we're going to have 9, and then on the bottom we're going to have 10. So we have 9 over 10, and then there's no common factors because there's no numbers that go into both 9 and 10. So our answer is 9/10, or 9 over 10. Okay? All right. So hopefully that's not too bad. Most people find adding and subtracting like fractions to not be too hard. Now, let me see if I can find one more problem that's like fractions, just to have a little bit more practice. Okay. So we're going to do this next problem, which is example number 6, since we just did example number 5. Okay, so example number 6. For this one, we have 4x over 16 minus 7x over 16 minus 21 over 16. Okay? 4x over 16 minus 7x over 16 minus 21 over 16. And I have no idea why I made that so big, but I can zoom out a little bit here. Okay? So for this one, notice once again they're all like fractions because they have the same denominator. So we're going to keep the denominator and then add or subtract on the top. So what that's going to look like is on the top we're going to have 4x minus 7x minus 21. And that's all going to be over our denominator 16. Okay, and it's up to you whether you want to write the 16 down in the denominator, but don't forget that it's still there. Okay? And then we can combine the 4x and the negative 7x. So these two are like terms, so we can combine those, but we can't combine those with the negative 21 because that's not a like term, that doesn't have an x. Okay, so 4x minus 7x actually gives us negative 3x. So on the top we get negative 3x minus 21 all over 16. And you might think you'd be able to simplify this more. The only thing you might be able to do is you could factor out a negative 3 on the top. But because we're not doing factoring yet, they don't actually want you to do that. So you don't need to factor out a negative 3 on the top. And there's nothing to simplify here. So this is actually our answer. Negative 3x minus 21 all over 16. Okay, so that is adding and subtracting like fractions.